今天回去你电脑可以再开一下试试。
后来我也有开了。
对。现在怎么这么少人呢？塞一下学分是吧？
对，本来就不可能。
Okay, time to start. I'm Ed Zaruska, module leader for Comp 3207, so any problems? The numbers have been fluctuating a little bit. As of this morning, we appear to have seven to 8 students, which is good. Tomorrow is a deadline for anybody changing modules, so things should really be pretty much stabilized by then. And that's also the time that we've set for you organizing yourself into teams for the group coursework. This is where we are at the moment. For some reason, we don't have a Team A, which is surprising. If anybody wants to be Team A, grab the spot. A couple of years ago, we had a bunch of students almost waited a full night for this to open, so they could be Team A. Whatever. If I don't have anything else, I'll move the Team Q up there. As far as I can see, the only problems that we have are this guy here, who isn't registered. Is he here? Okay.
But he's in our team, and he moves the module, like he just changed his mind to take this module. That's what I...
Is he going to take it, or is he going to take something else?
No, I'm under the impression that he's going to take this module. He
needs to register, yeah, okay. And there was somebody else.
Yeah, he's one of my
He's your tutee?
He's
Yeah.
my TT, and I signed him transfer request so he can move off from this module to be in management instead.
Okay, so he's going. So I'll take him out of there. Okay, brilliant. The only other problems we have at the moment are we have a team of 3, which isn't enough.
Extending now. Extending, I'm going with a group and
Yeah. So that's all. You're going to modify this later on.
Yeah.
Yeah, brilliant. Okay. So we'll also have a team B up for grabs. Now everybody really should have met. Is anybody from Team C here? Yes, you're from Team C. You had a meeting?
Yes.
Okay, and everything's looking good.
Yeah.
Brilliant. And Team D,
Yeah.
you've met?
Yeah.
Good. E? Nobody from Team E is here. Team F?
Yeah.
Okay. And G?
Yeah.
Good. H?
Yeah.
Anybody from Team H here?
Yeah.
You had a meeting?
Yeah.
Good. K?
Yeah.
Yeah, okay, good. M? You had a meeting?
Yeah.
Brilliant. N? Anybody from N? Okay. Q? You had a meeting?
Yeah.
Good. And the extreme team. Okay, right. So, where are we? I'll come back to that in a moment. At the moment we're here on the slot. The end of JavaScript. 2 weeks of Python. Steve will be sending out a note about how he's going to organise that. I think the plan at the moment is the first week is going to be for people that are new to Python, introductory stuff, and bring your laptops along and code along if you want. And week 4 is for everybody talking about development strategies and so forth. But at the moment, that's the end of the lectures. We've got some JavaScript help organised because you've seen the deadline for that coursework. But there will be no more lectures and no more formal lectures currently scheduled for the module. The rest of it, I think, is self-explanatory. One thing I did want to show you was if you go back to previous years, and we just take last year for the moment, but it's all there. And if you look at what the group coursework was last year, then you can see, for example, the students that we had last year, many more teams. Many more teams last year. But after the deadline for the group coursework, all the reports are published. So you can see what each of those teams did. You read their 6-page report. The GAE link will probably work, but I'm not going to attempt to run it at the moment. I strongly suggest that each team has a look at what's been done in the past to get ideas, see what's feasible in the time available, and so forth. The other thing that I should stress to you is it's a very different module from most ECS modules. You really are thrown into the deep end. You have to work in your team, or for John's assignment for individually. It's a different way of learning. And if you want to do that, that's fine. If you don't want to do it, then you've got till tomorrow to select another module. Okay, I think I'll stop at that point and hand back to John. But first, are there any questions about the group coursework? We've tried to set the instructions clear. There is an FAQ. If you think of anything that isn't clear and it's not in the FAQ, email me and I'll add it to the FAQ. Okay, thank you very much. Sorry.
With library config files, if a library is generating their own config, does that count towards the code, the line of
I
code?
think you're saying if you want to use third-party libraries, is that right? If you use third-party libraries in your application, that's fine, okay? It doesn't count towards the line of code limit. You have to acknowledge it, of course. It's a hanging offence if you use stuff that you don't acknowledge, and it's plagiarism. Yes.
If you use a web framework in Python like Django, it
Django, yes,
it generates a load of
yeah.
settings.
I know, if you look back through the report, you see a lot of teams have used Django with varying amounts of success, I have to tell you. But one of the requirements is you actually submit the code, and I do say in the notes, I'm not sure you have read that part of the note yet, I haven't put the submission detail. No, I think I have got the submission details there. I haven't got the demonstration details. I say, look, if it's out there on the web, just give me a URL. You don't need to supply it. So I think I had 1 year. I had several teams giving me about 50 or 100 megabytes worth of Django stuff. And it's kind of crazy. Okay. Any other questions? Okay. Thanks, John.
Right, okay, so the last JavaScript lecture. Right. Today we're going to talk about 3 different things. So we're going to talk about Node.js to begin with. We're going to look at the Heroku platform, and then we're going to talk about coursework. And all these things play together because the coursework will let you play with all of these things. So, as I've already eaten up 10 minutes of the lecture, let me kind of rush ahead. We'll start with Node.js. What is Node.js? So Node.js is yet another JavaScript environment. Just a different environment. It's different to the web browser. It behaves differently and it's different. What's it for? Well, it's for building fast and scalable web applications. Really, or network applications. Doesn't actually have to involve web at all. But things that use network. You can also build local applications, actually. There's nothing stopping you using Node to build a non-network application that runs on your computer. The typical use is network applications. Fundamentally, it's what you call server-side JavaScript. It's JavaScript that's running on the server rather than running in the client. Behind the scenes, it's built on something called V8. So V8 is the JavaScript engine used by Chrome and Chromium. Developed by Google. It's got one really key feature. It's designed to support large numbers of connections using something called asynchronous I/O. Before we talk about what asynchronous I/O is, we first need to look at what blocking I/O is. There are 2 types of input and output. Blocking input and output is probably something you're quite familiar with. So if we look at a piece of code, like here, where we've got some result which is created as a function of calling, maybe calling a database, issuing an SQL statement. In blocking I/O, we have a line of code like this. When the interpreter of the code is running, it'll get to that line of code, it'll execute the query on the database, it'll get back the result, and then the code will continue running. Okay? So for the period which the database is doing all the work, your code stops running. Okay, your code is interrupted. It is blocked. Why is this a problem? Well, it means that your code is essentially sat there twiddling its fingers. It's performing no ops. If you want to build applications, web servers, this is a real problem because it could mean that if you've got multiple users trying to use your application at once, one user could block all of the other users from actually being able to do anything. There are ways around that, of course. The common way around that So if you're using a traditional web server, web application server, something like Apache, maybe using something like JBoss, the typical ways that they work are to create multiple threads. The problem is that threads are quite heavyweight objects. They take up a lot of memory. Typically, these application servers, they create one thread for every user. This can be problematic. Asynchronous I/O, on the other hand, so this is something that Node does by natively. Interestingly, it's something you can do in other languages. You can do it in .NET, you can do it in Java. There are asynchronous web servers in those languages. But the fundamental idea is that you would write a piece of code like this. So in order to do our database query, we provide the SQL statement, for example, but then we provide something called a callback function. So that callback function is a function that will be passed the result at some point in the future, but not immediately. There's no guarantees about when in the future that will happen. That will happen as soon as the database engine has managed to serve your request, get the results of your query. What does this mean? Well, it means that your application can continue to run. It can continue to do things. So all you told it is, well, in some point in the future, you're going to get the response back and then you're going to do something with it. But for the time being, carry on doing things. Carry on serving the users that are trying to use your application. Lots of advantages. No need for lots of prep. No dealing with multi-threaded programming. So I don't know how many of you have ever tried to write programs that are multi-threaded, but it can be quite difficult. This completely avoids that. You've of course got all the advantages. Lower memory usage. It's snappy, it's fast. If we look inside Node, Node is entirely based around the concept of asynchronous I/O. It only has, by default, a single thread. Although you can create others. You can create things that spawn other threads if necessary. But by default, you probably never need to do this. Okay, so Node is a JavaScript environment. All JavaScript environments have a thing called a global object. In Node, the global object is called a global. Catchy name. The global object has a property called global, so you can access it from any code. So just like a web browser, which has a global object called window, and has a property called window on that global object, Node has the equivalent global and its property global. Node's global object is incredibly lightweight, so actually in web browsers you've got loads and loads of things that the window object has. In Node you don't really have very much at all. So you've got the global property pointing to itself. You've got a thing called process, which tells you about the internal process that's going on, tells you about the Node instance that's running. You've got a thing called console. We've already seen this in web browsers. So this is used for debugging. It contains methods for logging. It's got a few other things. Actually, this sort of summarizes. So you've got things like class code buffer, which is a piece of code that helps you deal with binary data. You've got properties __ file name __ dir name. They refer to the current JavaScript file that is being executed by the Node engine at the given time that you look at the properties. In terms of methods, well, we've got these 4 methods here. Actually, these appear in web browsers as well, so these are actually quite common. But you've got set timeout and clear timeout, set interval, clear interval. What they do, well, the first one, lets you call a piece of code at some point in the future. Clear timeout cancels that, so if it hasn't happened already, you can stop it happening. Set interval makes something happen on a regular basis at some defined period R, and clear interval cancels that from happening. There's a few other things. There's a method called require, we'll look at in a minute. There's a thing called require.resolve, require.cache, require.exception. You can actually ignore those ones. There's a thing called module and a thing called export. These are all to deal with something called modules. Node modules are what make Node powerful. So you've got this global object, which really doesn't offer you much ability at all. You couldn't do anything with Node. We're just using the global object. You could write some pure JavaScript code, but you wouldn't be able to do anything. You wouldn't be able to, you haven't got internet access, network access, you haven't got file access. You, the best perhaps could write something like a calculator. But even then you couldn't even get input from the user, you've got no way of doing that. So, to solve those problems, that's what node modules are for. Node modules are things that add additional functionality. And the interesting thing about these node modules is, lots of them are written in JavaScript, but some of them are what are called native modules. They're written in languages like C and C++. So they enable, by writing them in these other languages, you get access to other things. So, for example, there are node modules, we'll see in a second actually, but there are node modules that enable things like file system access. Something that's trivial in C and C++ using the standard library. The node modules let you do that, give you the access to do that from your node application. There's a stack of built-in modules. Okay, and these are really well documented. So if you want to do file access, then you'll find there's an FS module, file system module there. There are other modules. There's an SS module for writing a session in your page. There's a buffer module for dealing with buffers of data, so on and so forth. Perhaps the most important, from the point of view at least of anybody who's trying to write a web application, is the HTTP module, because that's the one that lets you write a web service in Node. So, we'll come back to that in a second, but let's first of all look at how you'd include a module in the code. Well, that's what the require method is for. So the require method of the global object lets you require a module. And we can do something quite easy like this. We can say require HTTP. We'll load the HTTP module into your code, and then you can use it. All the built-in modules are available in the same way. Okay? Any modules that you define yourself, because you can write your own modules for your application. You can load those in the same way. Sometimes, though, you want to use external modules. So modules that are being written by a third party. There's an entire ecosystem of really good Node modules that do all sorts of different things. Again, we'll look at some of those in a minute. If you want to use one of those external modules, then you do this using a tool called NPM, the Node Package Manager. And Node Package Manager is a bit like something like Yum or apt-get. So for those of you who use Ubuntu and you install packages on Ubuntu, you quite often type apt-get to install whatever. The Node Package Manager is very much like that. It's a thing for installing Node packages, Node modules in your application. Sometimes it'll install binary versions, sometimes it'll build things from source. It's pretty transparent. So the NPM tool, fundamentally, it relies on a file called package.json. I'll show you the content of one of those in a minute. But this package.json file declares what modules, what external Node modules your piece of software is going to use. You specify the name, you specify the version. Once you've got that file, so initially that file can be created on the command line by calling the command called npm init. You can manipulate that file automatically from the command line by just running the command npm install -save and the name of the module, and that will automatically insert the module into the file, download, install it, and compile it for you. If you just run the command npm install, it'll read the package.json file, and it'll go through and parse out all of the modules that you've declared and install those into your application. If we just look at so here's an example of a package.json file. This will become very apparent to you because this will be the one that you'll be given for the coursework. But this file it declares a number of things. So it's got the name of your application, it's got your name, it's got description of the version of the application. It's all the metadata around your application. A bit further down, it's got some important information. So actually, the bit that's really, really important is the bit that starts with dependencies. So the block of dependencies there, they are the node modules that are going to be installed. So we can see that, for example, this application is going to use a node module called Pug, and it's going to use a version greater than version 2 of that module, or 2.0, not beta 6 to be precise. So that's kind of the contents of the standard package.json file. Okay, so if you want to write your own modules, well, most of the time your own modules will literally be a JavaScript file containing some code that you write. And why might you create your own modules? Well, it might be that you want to organize your code. You want to group related functionality together. So maybe you've got a selection of utility functions and you want to put them all in the same file, or you can just put those in one node module, keep them all together. Potentially you'll have different classes in your, or different, you'll define different types of objects to use in your application. Again, you might put those in different files just to keep things together. If you've got those, then you require it normal, but you use a relative path to load them. Modules are great because they don't enable you to pollute the global namespace. So any global variables that are defined within a module will actually be scoped to that module only. They can't escape. If you want to export things from a module, you have to use a thing called module.export. So you'll say module.export equals an object, and that's the only thing that escapes from that module definition. The thing that module.export is set to will be what is returned by the required statement in your code. So you can do some quite clever things here to hide this code. You can essentially make private methods and private variables, which is quite useful. So from the point of view of the course book, we actually saw the style, but these are some of the things you're going to use. Actually, I forgot to update this bit from the slide. So the second one that says Jade, that's now Pug. It's an HTML templating engine that they recently, over summer, changed the name to say Soon, so they used the name Jade. So they call it Pug instead, because it makes sense, of course. You've got others, so you've got Express, which is a really popular Node.js web framework. Sequelize, which is a object relational manager for connecting to databases. So it lets you convert SQL databases into JavaScript objects and vice versa. A thing called Sequelize fixtures, well, that loads sample SQL code or sample JavaScript objects into your database as it starts up. The SQLite free module lets you have a local SQL database for development only. Okay, so it wouldn't be used for deployment. You wouldn't use SQL to deploy your web application. So you use it for testing locally. For deployment, you will obviously choose your own database. For the point of view of this coursework, we're going to use Postgres. String, which has got some string modules, but also things that manipulate strings, make them all uppercase, lowercase, do various tests, so on and so forth. Finally, perhaps the most important one for this coursework is the WebSockets implementation WS. That enables you to create servers that serve WebSockets. As a quick example, is some code, not very much code, but this is a basic Node.js web server. Okay, so we start by requiring the HTTP library, the HTTP module. We create a server, and we pass a callback, and in this particular case, the callback is basically saying what happens when you get a request. So a web browser asks some data, this callback is going to be called and decide what to serve up. Our web server in this particular case is very dumb, so irrespective of what you ask for, you're going to get the same response. It's just going to say hello world. We then start our web server. Once we've created it, we start listening on a port Because of the lease, we're going to use port 1337. And okay, finally, we just have a little line to say that this is running. If I actually run this code, so there's the code subline. If I run it on the command line, like so, you see it starts immediately, it's pretty fast. And if we go to a web browser, let's go ahead to port 1337, we can see that they work. See what I mean about irrespective of what the path is. We go to a/a/a on that, we're still going to get the same response. But of course we could write our callback method to serve different content for different URLs if we wanted to. Okay, that's Node in a nutshell. It's really that simple. Okay, it's literally just an engine that lets you run JavaScript code. All of the power comes from the modules that you can use. Move on a little bit, Heroku. So Heroku is a cloud platform as a service. It supports loads of different languages. Behind the scenes, it's running Ubuntu, but you're never ever going to see that. Actually, behind the scenes, it's running Ubuntu on Amazon EC2 nodes. So there's a bit of terminology to get your heads around with Heroku. So a Heroku application is the source code of your application. A dependency description, i.e. the package.json file, so the thing saying which libraries, which modules you're using. A thing called a proc file, which declares what Heroku is expected to do with your source code, what it's expected to run. Applications on Heroku are deployed in a really interesting way. They're deployed by you pushing your source code with Git to Heroku. This does lead to some interesting questions, because it means that you're sharing your application source code with someone else, with a third party. But for the point of view of this course, we're going to assume that we trust Heroku implicitly with our code. So what happens, you push your code to Heroku, it will compile it for you, run, and then it serves it. And when it's compiled, Heroku calls the compiled code something called a slug. And so the slug is basically a bundle of the source code, all of the dependencies, all of the compiled and generated code, everything that you need to run your code, all bundled up together, ready to run. That slug is executed in something called a dyno. So this is basically the worker. Heroku dynos are, for those of you who know Docker, they're basically like Docker containers. They're containers that let you run your code in a operating system level virtualization environment, a container or jail. Theoretically, your code shouldn't be able to interfere with anybody else's. It's locked down to that container. In that container, you've got access to a local file system, but it's not restricted. The moment that dyno shuts down, the file system disappears. Word of warning, when it comes to the coursework, be really, really careful that you configure it correctly so that it uses Postgres as the database and not SQLite, because if you put SQLite on the local file system on Heroku, what you'll find is that you run your application, it all looks like it's working. You go away for an hour, you come back. During that hour, Heroku will shut down your application and split it back up again when you came back to it, and your database will have disappeared. Okay, so you've got to be really careful. So no consistent data on file. There are different types of dynos that you can configure with Heroku. The one that we're perhaps most interested in is the thing called the web dyno. So this is a dyno that gives you access to an open port in order to serve websites. This port will not be port 80 like you'd normally expect. It'll be some other port. It'll be completely randomly assigned, probably depending on the number of other dynos that are running on the same piece of software. If you want to find out which port your slug is running on inside the dyno, then you can actually use Unix environment variables in order to pull that out. different types of dynos do different things. So there are dynos that are suited to database processing. So they're for long-running tasks that you might spawn up, you might run overnight, and you might shut down. There are dynos that are suited to serving databases, and they of course have persistent storage. You don't really want your Postgres database to shut down and lose all of the data. You can configure how many types of dynos your application uses. So you can configure how many, well, the maximum number of web dynos that your application uses. More web dynos means that the more your application can scale. The more dynos that you add, the more it's going to cost you. So Heroku also provides things called add-ons that enable you to have extra functionality. So for example, access to databases, access to other cloud services, so on and so forth. There's a thing that's kind of invisible to you that's called the Heroku HTTP router. That's something that takes requests to your application for a web browser on port 80 and forwards them to the correct dyno on the correct port. Okay, so transparently, behind the scenes, Heroku is routing the data, the request to your application to the right dyno. If you've got multiple web dynos, then it does load balancing, so different users will potentially get distributed to different dynos in order to spread the load. Heroku provides a thing called the tool belt, which is a command line application that lets you manipulate everything. So whilst you can go and use Heroku dashboard, which is their web interface, you don't have to. You can use the tool belt and do things from the command line. You can create applications, you can create instances, you can set a number of dynos, everything. You can do it from the command line. Good news, Heroku is free. Well, to an extent. You get about 750 hours, dyno hours a month, free. So that's quite a lot of time. You get a free small database, which I think off the top of my head allows something like 10,000 rows. Obviously, if you want to use more, then that's what you start paying for it. Add-ons, you typically always get charged. Okay.
They've changed their pricing model recently.
Okay.
So it's not 750 hours anymore. I think you have like 16 hours free a day and then you need to shut off.
Okay. Well, that's going to be about the same anyway.
Well, yeah, you can't have an app that runs 24 hours.
Yeah, okay. But the point of view of the course work doesn't really matter, that you're not going to use it. So, unless you leave the coursework until the last minute. So if you do it until the last minute, then you might run into problems. Okay. Okay, coursework. So we've got about 5 minutes left. So, the coursework, what we're going to do is get you to build the game. And we're actually going to need to build a really, really old type of game. Something called a multi-user dungeon. The multi-user dungeons were really, really popular in the 80s, probably even the late 70s. They were computer programs that enabled multiple users to log on, typically to a mainframe computer, so a computer that would take easily the size of this room. You'd log on using a remote connection over a telephone line, probably using an acoustic coupler. So I think we saw a picture of one of those. It's basically something you put your telephone handset onto, and it makes sounds, and it enables you to transfer data at incredibly low speeds. So these applications were completely text-based, but inside, multiple users would log on, they could interact with each other. So it was a bit like a chat room. But more than that, it was actually a complete virtual world, because users could create objects, could create rooms, could create pathways between rooms, so you could create doors that link between rooms. You could move around, you could interact with things. And that's fundamentally what we're going to do. I'll give you a quick demo. So the mod that we're going to use is going to be called ECS mod, and it's got a web interface that looks a bit like this. If you connect to it, you get a terminal interface, and we can log in. So actually, if I log in as me, okay, so I've logged in, and I'm now in a room So my character is in a room. In this particular case, because it's an ECS mode, my character is in the Mountbatten foyer. You can see that there's a description of the room. There are some things in the room. So actually the contents of the Mountbatten foyer is Erica the Rhino. If I want to interact with Erica, I can do that. So maybe I want to get on top of Erica and ride her. Although it turns out that that's a really bad idea because I step off on the floor. I can move around. So I can go into Zeppler. This was kind of written last year, so there were vending machines in the Zeppler foyer. They've gone now. But there's various things in the Zeppler foyer. There's Eric, who we can interact with. There were some chairs, so on and so forth. So for this coursework, we've given you the code for this application, sort of. Unfortunately, the developer left halfway through writing the code and never finished it. So your task is to finish the implementation and then get it deployed on Heroku. We're going to give you what you start the starter implementation. So there's bits that work, there are bits that don't work. You've got to figure out what those are. You've got to add the rest of the functionality. There's no particular formal spec, but the developer did leave the instruction manual for the game lying around. So you've got the instruction manual to work from in order to figure out what the features are that need implementing. There is some little bits that might constitute a formal specification in there. Some of it you're going to have to use your imagination and figure out how it's supposed to work. So you're going to put together all of these pieces, you're going to finish building this application, and deploy it. And you've basically got until, I can't remember what the date is, you've got until sometime in November. Give me a second. Okay, so till the 23rd of November to do this. Word of warning, I think I already mentioned this before, but this coursework is designed to take somewhere between 40 and 50 hours to do. 40 and 50 hours of coding. Okay, so there's quite a lot of code that needs writing. The developer, he really did leave it in a bit of a mess. When you've submitted the coursework, we're going to mark it, obviously, and we're going to assess you on a number of things. We're going to assess you on how well you've actually implemented the missing features according to the user guide, and we've got some automated tests that'll check that. But we're also interested in other things. We're interested in how well you use the language, the JavaScript, so how good your JavaScript code is. We're interested in your development methodology, so how well you use GitHub, for example. So we're going to look at all of those things, and they all feed into the masking. The full details are obviously available through the Handling link, and they're actually on the wiki. So there's a full specification for this coursework on the wiki. There's links on here to the user guide. There's some sort of programming notes that are going to get you started. There's a sample transcript. So actually, the sample transcript is important. It's basically an interaction between a pair of characters in the game, sort of showing you what to expect. I think that's pretty much it. Yeah. Okay. So, slide quickly. GitHub. So the reason at the beginning of the course we asked you to provide your GitHub details was so that we could give you the starter code for this for this coursework. So hopefully everyone in this room has got access to that. You should have all been sent an invite to a GitHub organization yesterday. If you weren't, come see me again. There were definitely 2 people who typed in their own GitHub usernames, and there were 2 people who signed up to the form after I'd actually gone through and run the code to generate the repository. So find me after this, you haven't had an invite, and you haven't got access to the code. Obviously, because we've created those GitHub repositories, we can see what you commit. That's kind of how the coursework is going to play out. We're going to keep an eye on what you're doing. One word of warning, please, whatever you do, do not fork the repository. The repository we've created is for you to use directly, okay? So I know that lots of people, they tend to go into GitHub and the first thing they do is fork the repository to make their own copy. This is your copy, use it directly. If you fork it, then it becomes difficult for us to keep track of. Right, so as I said, Steve's going to start Python lectures on Tuesday. In terms of help with this coursework, we're going to run kind of drop-in sessions. And what we've done in previous years seems to work quite well. So I will go over to the virtual lab at a certain time each week, and I will sit there, and I'll take a poster out with me to help ask questions. I'll sit there and we'll be there to help you for an hour, maybe 2 hours a week. Next week, I intend that we're going to do this on Wednesday between 1 and 2, I think. And we'll do Wednesday 1 and 2 the week after. And then following that, for the following week, after that we'll do it in the lecture slots on Tuesdays. So I think we'll do the midday lecture and the 2 o'clock lecture. And we'll be sat in the virtual lab waiting to answer your questions. Okay, are there any questions? No? Okay, so as I said, if you haven't got the GitHub stuff, come and speak to me right now. If not, well, it's been a pleasure. Best of luck with the coursework. I guess I'll see you in the lab drop-in sessions because you will get stuck, guaranteed. Or rather, you'll have difficulty in testing the instructions. Probably more.